Kubernetes is a powerful open source system initially developed by Google for managing containerized applications in a clustered environment. It aims to provide better ways of managing related, distributed components and services across varied infrastructure. Welcome to the final section of our course on reactive microservices in .NET Core. In this section, we'll see what Kubernetes is and how to configure and install Kubernetes on Windows 10. Later, we'll create Kubernetes artifacts for installing and configuring our applications on the local Kubernetes cluster and test our application. We'll also go through some of the concepts like how to scale independent microservices, monitor them, and use them in a production environment. In this video, we'll see some of the basic Kubernetes concepts, the architecture of the system, the problem it solves, and the model that is used to handle containerized deployments and scaling. Before we dive into setting up the components and understanding the architecture, it's better to get comfortable with some basic Kubernetes glossary. A container is the smallest unit in the Kubernetes world. The main purpose of Kubernetes is to manage, deploy, and to a certain extent monitor containers. Kubernetes management is not limited to Docker containers. A pod is the management unit in Kubernetes comprised of one or more containers. Each pod has its own unique IP address and storage namespaces. All containers running inside the pod share these networking and storage resources. Pods are mortal, which means when a pod is deleted, it's gone for good. A node is the host that the container or pod runs on. This can be a virtual machine in the Kubernetes cluster. A deployment is a new way to define the desired state of pods. A pod by itself is mortal, but with a deployment, Kubernetes can make sure that the number of pods that the user specifies is always up and running in the system. A deployment specifies how many instances of a pod will run. This is called a replica set. A YAML file is used to define a deployment. Namespaces are a way to create multiple virtual Kubernetes clusters in a single cluster. Namespaces are normally used for wide-scale deployments where there are many users, teams, and projects. You can think about namespaces as environments in Kubernetes world. For example, in a single Kubernetes cluster, you can create multiple namespaces like test, acceptance, and production, and deploy your application on each namespaces and promote them to a higher namespace. As pods have a short lifetime, there is no guarantee about the IP address they are served on. This could make the communication of microservices hard. Hence, Kubernetes has introduced the concept of a service, which is an abstraction on top of a number of pods, typically requiring to run a proxy on top from other services to communicate with a virtual IP address. Services are used to expose containerized applications to origins from outside the cluster. This is where you can configure load balancing for your numerous pods and expose them via a service. Kubernetes follows client-server architecture. Kubernetes architecture has the following main components: master nodes, worker or slave nodes, and a distributed key value store. The master node is the entry point for all administrative tasks which is responsible for managing the Kubernetes cluster. It's possible to configure or create more than one master nodes for a high availability mode. For managing the cluster state, it uses etcd, in which all the master nodes connect to. etcd stores the configuration information which can be used by each of the nodes in the cluster. It is a high availability key value store that can be distributed among multiple nodes. It is only accessible by the Kubernetes API server, as it may have some sensitive information. The API server is the one which provides all the operation on the cluster using the API. Kubernetes API server is the central management entity that receives all REST requests for modifications to pods, services, replica sets, and others. It serves as the front end to the cluster. Also, this is the only component that communicates with the etcd cluster, making sure data is stored in etcd and is in agreement with the service details of the deployed pods. Controller Manager runs a number of distinct controller processes in the background to regulate the shared state of the cluster and perform routine tasks. When a change in a service configuration occurs, For example, replacing the image from which the pods are running or changing parameters in the configuration YAML file, the controller spots the change and starts working towards the new desired state. Scheduler helps schedule the pods on various nodes based on resource utilization. It reads the service's operational requirements and schedules it on a best fit node. For example, if the application needs 1 GB of memory and 2 CPU cores, then the pods for that application will be scheduled on a node with at least those resources. The scheduler runs each time there is a need to schedule pods. The scheduler must know the total resources available as well as the resources allocated to each workloads on each node. The main components on the node are Docker, Cubelet, and kubeproxy. The first requirement of each node is Docker, which helps in running the encapsulated application containers in a relatively isolated but lightweight operational environment. Cubelet is the main service on a node, regularly taking in new or modified pod specifications and ensuring that pods and their containers are healthy and running in a desired state. This component also reports to the master on the health of the host where it is running. kubeproxy is a proxy service which runs on each node and helps in making services available to the external host. It helps in forwarding the request to correct containers and is capable of performing primitive load balancing. It makes sure that the networking environment is predictable and accessible at the same time it is isolated as well. It manages pods on node, volumes, secrets, creating new containers, health checkups, etc. Now that we have an overview of Kubernetes and how it works, let's have a look into how we can set up Kubernetes on our development machine so that we can start using Kubernetes for deploying our application. To install and configure Kubernetes, you need to open Docker on desktop and enable Kubernetes on Docker. So let's go to Docker. So I'm right-clicking Docker and then Settings. And if you go to the settings, there is a section called as Kubernetes. And if you click on that, and you can enable the checkbox, Enable Kubernetes. So this will make sure that Kubernetes is running as a single node cluster. That means that you have one master node and one slave node, and this is where the Kubernetes cluster runs. And also you can make sure if you want to show the system containers, etc., you can also click on this one. But I prefer that you don't use this one because then you'll accidentally delete some Kubernetes containers and you don't want to do that. So if you click on apply, that will take some time and make sure that Kubernetes is running on your machine. So I'm going to click on apply and then click on install. And then this will be running in the background and Kubernetes will be up and running in a short time. So this takes some time. So let's come back after the installation is completed. So to make sure that Kubernetes is installed correctly, you can use the kubectl commandlet and type in version to see whether what client version you have and the server version you have installed on your machine. So I'm going to type in kubectl version. And this will display the client version and the server version. So you can see the server version is with a major version 1 and minor version 10, and I do have the same client version. And also if you want to run some commands and to check the state of your Kubernetes, you can use the kubectl command. For example, I want to list out how many nodes are there in this installation. So I'm going to type out kubectl get nodes. And this will list out all the nodes running in my installation. So you can see that I have one node and it is the master and also the slave node. But if you have a cluster with multiple nodes, it will show you all those details over there. For example, you can check out how many deployments are there or how many pods are running by using the kubectl command. So I'm typing in get pods. So that means it will list out all the pods running on my machine. And I will see there is no pods running because we haven't run anything over here. But you can also use the namespaces command, because if you give get pods, it's going to list out the pods from the system namespace. But if you want to get the pods from the default namespace, for example, so I'm going to type in kubectl get pods -n default. Then if there are any pods in this namespace, it will list it out of there. In the next video, we will see how to create deployments and services, and then we will install some microservices, and then we can list out the pods in the namespace which would install the services, and then you can see all the resources over there.